Everyone, it's Actuary Dude here, looking at another exam question. So it says a coin is biased so that the probability of throwing a head is unknown constant p. And it's known that p is got to be either 0.4 or 0.75, and prior beliefs about p are given in the distribution. So this is the prior distribution. So the coin is tossed 6 times, and 4 heads are observed. So what's the posterior distribution of p? Well, it's always important to remember this little formula here. And basically, a good way to figure this one out would be to use a tree diagram. So what we're saying is, before we even toss the coin, if I tell you I've got 2 coins and 60% of the time I use the one that gets heads at 0.4, so 40% of the time, and my other coin I use 40% of the time, and that one it gets me a heads 75% of the time. So we can look at it like this, where p is going to be equal to 0.4, and then we have a 40% chance that I use my more biased towards head coin. And then I say to you, alright, which coin am I going to use? And I'll give you a bit of a hint. I'm going to flip the coin 6 times, and the number of heads that come up, you can then try to figure out which coin you think I'm using. So I do it and I get 4 heads. So what we can work out is, if I were using the coin that's got p equal to 0.4, what would then be the chances of getting 4 heads? And that's just using the simple binomial formula. And so we just do it like that. And then, and for this one, I say, okay, well, let's work it out to see what the chances of getting 4 heads would be if I use the more biased coin. And that's 0.75 I got 4 times, and 0.25 I got twice. And then once we've got that, we're going to multiply that, because we're going to say, all right, well, that's the chances of getting that many heads, but we only use that coin 60% of the time. This is the chances of getting 4 heads using this coin, but we only use that 40% of the time. So what we have to do is just multiply that one by 0.6 and this one by 0.4. So what we've done over here is we've taken this whole bit is the top line over here, and this whole bit here is the top line over there for each one that we're trying to work out. So in this posterior distribution, we're trying to find 2 things. We're trying to find the probability that p equals 0.4 given that we got 4 heads, and we're also trying to find the probability that p equals 0.75 given we got 4 heads. And then depending on the answers you get, you can try to decide on which coin I was using. So this whole thing divided by the sum of the 2, and this whole thing divided by the sum of the 2 will give us each of these answers. So let's work that out in Excel and see what we get. So let's start with the very first coin, and we're saying I first flipped it 6 times, I got 4 heads, so there's 15 times that can come up. The chances of getting a heads was 0.4, and we got that 4 times. The chances of getting a tails is 0.6, we only got that twice. So each of them multiplied by each other is the chances of getting 4 heads out of 6 tosses, but with that coin we're only using it 60% of the time. So that's that one over there. And now for the other coin, we're doing the exact same thing. We flipped it 6 times, 4 heads. It's a 75% chance of getting a heads, getting that 4 times. It's a 25% chance of getting a heads, happens twice. The product of these 3 numbers here is the chance of that happening based on the biased coin, but we only use this coin 40% of the time. And so the chances of getting 4 heads overall with the 2 coins together is this amount over here. And so all we have to do now to find out the posterior for the first coin, this is the probability of getting 4 heads out of 6 tosses, given that the coin has a probability of getting a heads of 40%. I think there's a mistake over here. Sorry, there shouldn't be a times. They should be added together. Let's do that again. Same thing. And then the probability of getting 4 heads, given we've had 6 tosses, where the coin is a 75% chance of getting a heads, gives you this figure. So it's probably more likely that we're using that coin, but either way, that's the answer. That's the posterior distribution of each of these. So you would just take this number here and apply it here, this number here, and apply it there. Thanks a lot for watching.